Hello everyone, welcome back to the math tutor. In our previous video, we discussed relation and their various types. If you missed that video, please check it out. In today's video, we do a special problem that cover all the doubt and confusion about relation and their types. So let's start. Suppose we have a set A one, two, three up to 14. And I am defining a relation on the set A. Define relation R on set A as xy, order for xy such that 3x minus y equal to 0 for all xy belongs to A. This relation is defined on A, that is relation is from the set A to A. Okay, and now we have the following questions. Okay, find range, domain and codomain of R. Secondly, check how many relation possible in R, possible in A. And also check whether R is reflexive, symmetric or transitive. Also state whether it is equivalence or not. Equivalency test. Test the equivalence. Okay. So let's start. So we first write the relation in roster form. So the range, domain and codomain will be clear. Here codomain is always the right hand side set. Here this right when we define this relation R from A to B, this set B is called the codomain. Okay, so here the codomain is clearly A. So here codomain A of R is A. It is clear. Now we write the relation in roster form. R is given as xy, given that xy such that 3x minus y equal to 0 for a xy belongs to A. Now simplifying this, we can write this as 3x equal to y for all xy belongs to A. That means we take value in x and find the value of y, and that y should be in the set A. Now I am writing this in roster form. For x equal to 1, what will be the y? Y is equal to 3x, x equal to 1, so y equal to 3. And 3 is in the set A, so 1, 3 is in the R. Similarly for x equal to 2, y will be 6 and 6 is in the A. And for 3, y will be 9. And for 4, y will be 12. But for 5, y will be 16. And 16 is not in the set A. So, and for 5, 6, 7, 8, the values of y are not in A. So, we cannot consider that. So this is all our relation R. Now from the definition of range, I have clearly stated that the in set R, the second element, the set of all second element of the order pair in R is the range set. So here the range of R will be the set of second element, that is 3, 6, 9 and 12. 3, 6, 9, 12. This is the range. Similarly, what I have stated about domain. Domain is the set of first element in R, that is 1, 2, 3 and 4. Now this is all about range, domain and codomain of the relation. Now how many relation possible in A? We have formula. Now we have learned in our earlier video that if a relation R is defined from A to B, okay, and number of elements of A is P, number of elements of B is Q, then possible number of relation will be 2 to the power PQ. So here how many relation is possible? Here relation is from A to A. R is defined from A to A, and number of elements of A is 14. So how many possible relation? How many relation will be possible? Number of relation will be 2 to the power P and Q, that is A to A, that is 14, 14, that is 14 into 14, that is 196. This number of relation is possible in set R. Now we check the equivalency, that is reflexive, symmetric or transitive or not. How the reflexive property is defined? Reflexive property is when we say relation R is reflexive if for every A belongs to A, if the order pair A and A in R, then we say the relation is reflexive. But here it is clearly seen that we have no 1 1 2 2 3 3 4 4 5 5 or 14 14 in R. This doesn't belongs to R. So R is not reflexive. Similarly, what states the symmetric property? Symmetric property states that for all AB belongs to A, if AB belongs to R implies BA also belongs to R, then we say the relation is symmetric. But here we check for 1 3. Okay, for 1 3 we have to, for 1 3 belongs to R implies 3 1 also belongs to R. But this condition is not, 3 1 is doesn't belongs to R, so it is not symmetric. For 2 6 also 6 2 is not in there, not there. Okay, for 3 9 9 3 is not here. For 4 12 4 is not here, so it is not symmetric. And similarly, what is the transitivity? Transitivity states that for all A B C belongs to A, if AB belongs to R, BC belongs to R, implies AC belongs to R. So it's also clearly seen from here that here 1 3 belongs to R, and 9 also belongs to R. But this should implies 1 9 also belongs to R, which cannot satisfied here. So this is clearly not transitive. Hence it is not equivalence. Hence it is not equivalence. Because equivalence, when we can say set is equal, a relation is equivalent if the relation satisfies all the three properties, that is reflexive, symmetric and transitive. We say the relation is equivalence relation. So the relation here is not equivalent. Okay, this is all about the relation, sorry, types of relation and range, domain, codomain. Okay, any doubt, any query, please comment. Thank you.